Today video is about full adder. Full adder is a combinational circuit that forms a arithmetic sum of 3 input bits. It consists of 3 inputs and 2 outputs. Here the 2 inputs are denoted by A, B and the additional one is Cin, which performs the carry. Here the outputs are sum and carry. Now let's go to the truth table. Here the possible combinations are 3 and executes 8 possible inputs, and this is the sum and this is the carry. So we know that 1 plus 1 is equals to 0 with a carry of 1 and 1 plus 0 equals to 1 with a carry of 0. From the truth table we have derived the Boolean expressions as sum equals to A XOR B XOR C and carry is A plus B into C plus AB. So from this we got the circuit diagram. Here the A, B and C are the inputs, sum and carry are the outputs. A and B are given to the XOR and also for AND, and the Cin with the XOR output, another XOR gate is given, that is given as the sum, and the 2 AND gates operation is given to the OR, and we will get the final carry as the output. Now let's go to the simulation of program. Now let's take to the iCarAS Verilog and go to the bin. We have to write the program in a new text document. Since we have already dumped it, let's go to the fulladder.v file. This is the whole program of the full adder, and let's go to the module definition. Here we have to start the program with the module keyword and assign all the inputs and output variables in the program. A, B, C are the inputs, sum and carry are the outputs. This is the functionality. Let's go to the assigning. Assign is the keyword where we give the input to the output, and same the carry is also given. We have to end the program with end module keyword. Now let's go to the test bench to test all the test cases. Rick and wire are used to store the inputs and outputs. A, B, C are the inputs that is given to the register. Register stores the input temporarily and wire stores the output permanently. Now let's go to the instantiation of the main program to the test bench program. Here we have to include the main program and we have to use a variable name that is duck or your own name, where you can instant the main program into the test bench. Now let's test the all possible input combinations. Here we have to use initial begin keyword since we have multiple inputs to execute. Dump file and dump wars are the 2 instructions where we have to see the GTK waveforms. So we have to give all the test cases and give a delay of 10 nanoseconds. Give all the possible 8 input combinations and give the command $s_finish where to terminate the simulation, and we have to use the end to end the instantiation and end module keyword to end the whole program. Now let's go to the command prompt to see the output. This is the command prompt where we can see the output. iVerilog space -0, include the file name, here this command says that iVerilog -0. Here the test says that we have to use an object to see the output and we have named it as test. Since there is no errors, we see the empty blank. To see the output we have to use the command vvp and the object which we use it to see the output, here the test. This is the output of the full adder. Let's see the output in GTK waveforms. For that we have to use the command GTK wave space test bench name .vcd. Here we get the GTK waves. So click on the test bench. We have got all the inputs and outputs. Now insert all those. By this, we can see the output virtually in waveform in the output. Thank you.